Alright, welcome to Jaka Quantics. Now in this tutorial I'll be putting us through how to measure drainage, storm water drain. Right, because not all drainages are storm water drainage. It's actually the one you have in your mechanical designs. Alright, so basically we'll be looking at stormwater drain, how to measure drainage, stormwater drain basically. And we have this drawing here. This is the drawing we have, and it says this is a U drain, right? 1 meter by 0.8 meter depth, 1 meter width, 0.8 meter depth. Right, now it is a U drain because there are other drains. Drains can also be trapezoidal. Drain can also be V drains. You must have seen those kind of drains, but what we have is a U drain, is what we're using as a reference in this particular tutorial. Now basically drainages are structures that we use to convey and manage rainwater runoff. I think if I put it like that, right? There are structures that we use to manage and convey rainwater runoffs, majorly from surfaces, maybe from a building, from the road, from different surfaces, right? And of course maybe they channel them to a stormwater collection, or maybe a stormwater sewer, or whatever it is, but it is majorly to manage and to convey rainwater runoffs. Okay, so this is the drain we have. Like we said, of course it has cover. You can see the cover, right? The drain cover. You can see the drain cover also, and you can also see it from the drawing here. 1 meter wide, 0.8 meter depth. That is the drain. What else do we need to know? Okay, what the blinding is 50 mm. Let me zoom in. The blinding is 50 mm, right? Grade C. And if you notice something here, see, both the blinding and the drain are at the same position. They are the same. Majorly you may say, okay, maybe to extend a little, but this drawing says they are on the same position. All right, so not all drawings are like that. So you need to understand your drawing and understand the peculiarity of your drawing so that you can work accordingly. If it's an exam and you now when you say the drawing, the blinding will extend, you will talk in the drawing where you see how the blinding is extending. So understand your drawing and work accordingly. Okay, and of course, okay, this is the reinforcement details. You can see here. Let me zoom in. Right, you can see the main bars. You can see the runners. See this thin line, right, forming the U, right, of the U drain. Those are the main bars. Then you see this one, this dotted line showing that something has been cut, right? They form the runners or the distribution bars. All right, I hope we get that from this particular drawing. All right, so let's see how this is going to be achieved. So this is what we have here. This is the drain. We're working for a 100 meter drain. This is drain drawing number B2CL1205 Chaka. Stormwater drainage system with length of 100 meter. Reference SMM is BSMM4R, and of course you need to prepare your takeoff list. I've emphasized this takeoff list over and over again. It's just for your examiner in case there wasn't enough time, and of course you won't always get enough time. If it's the NIQS test for professional competence examination, you won't always have time because you still cannot finish. I don't know how it is now, but then you will have 3 hours and you will exhaust the 3 hours and you will not finish the exam. All right, so but if you have your takeoff list, it helps the examiner to understand, okay, this person knows what he or she is doing, but there wasn't time. Even when you don't know, prepare your takeoff list. You will have your mark on that regard. All right, so we have site preparation, cutaway, backfilling, concrete works, blinding, reinforcement, formwork. backfilling. But okay, when we get there, we cut away. Will there be backfilling? No, I doubt it. But let us see. All right. So excavation, our BSMM is section 1.5 for excavation and sand filling. BSMM 4R for excavation and filling is section 1.5, and of course I have to clear the site. Now if it's normally, drainage doesn't just come alone, or maybe in local environments, or they have already built the house and then they want to put a drainage so that to control water runoffs. But normally, say you have a road, and of course you have a drain beside. Alright, so by the time you clear both the road and the drain together. But now it is not the case. We're working on only drainage alone, so we assume we have to clear the sites where you have to do the drain. Alright, so this is basically what we have: site clearance. Alright, we have to clear sites of vegetation, growth. We have to grow up their roots as the case may be, and I have to dispose. The drain length is 100 meter. The width is 1 meter. This is end to end width is 1 meter. Of course, there's a wall and there's a wall. See what I mean here? Let me zoom in here. Right, this is what from here to here is 1 meter. That's what you see here, 1 meter. Right, but to out is 1.3, which is what we are excavating. All right, so that is what we have. That's why you see 1.3 here. So it is length by the width. I'll say there's no working space. You didn't allow for working space. BSMM 4R does not allow for working space. You have to build it inside your rate. Konjiko. Yawa. Alright. So having done, of course, the site clearance, now we need to excavate. Right. You say you didn't remove topsoil. You are going to dispose at the end of the day. Whatever you excavate, you are going to dispose it, so you don't have to remove topsoil. But if you want to go by the book, you remove topsoil for that small that's for excavation you need. But for a drainage, you are not going to remove topsoil. Right, but remember, if it's a road you're working on, you have to remove everything together then before you can start your drain. Right, I hope we get that. And okay, now if somebody puts topsoil, remove topsoil, will the person be wrong? No. If another person didn't put topsoil, will the person be wrong? No. All right, okay, now we have to excavate. Right, so that's section 1.5.6.2.1.0 of the BSMM 4R. With the drain length is 1 meter, hard one. The depth is 800 plus the base, which is 150. See it here. This is the depth, 800. Now the base here, see it here, is 150. I hope we can see it. See my cursor, 150. So 8 plus 0 is 0.8 plus 0.15. That gives us 950. Now the blinding is 50 mm. That makes it 1 meter. Koba to Ankane. Alright, so let's go. That is why you see excavation is 1 meter by 1.3 by 1 meter. Right? And of course, whatever I excavate, I have to dispose. That is why you see and dispose off site. Now you see and dispose off site. I use one stone here. I use one dimension for two descriptions. It also tells your examiner you understand taking off. Alright, let's move on. So that will be fast. Okay, now having done that, we go into concrete works. Now if you observe, according to this drawing, we are excavating this exact, blinding on the exact, right, and then we are going to do concrete works now. Okay, let me move what I want to say until when I get there. All right, now concrete works. We know our length. Total length of beam Right, it's drain, not beam. It's drain, and it's not 103, it is 100. Right, total length of drain is 100 meters. 100 meters. 100 meters, that is 100,000 millimeter. All right, that is it. All right, so and the width is 1.3. The blinding is 50 mm, which is 0.05. That's 50 divided by 1000. Right, I try as much as I can to put whatever I have here in millimeter. Your waste calculation must be in millimeter. Please take note, your waste calculation must always be in millimeter. Why? Whatever you're doing on your dimension sheet should be in meter. All right, so this is the blinding. Now, reinforced in situ concrete for the drain. Now we have the base of the drain. This is the base of the drain, and then we have the walls of the drain. All right, so this is what we have. Reinforced in situ concrete to base, and then to walls. To base, let me put it here. This is base, and then to walls. The base is 1.3, the thickness is 150, the length is 100. So 100 by 1.3 by 0.15. Alright, the same way also for the walls. We have two walls for the drain. This is wall 1, this is wall 2. Now this thing is going 100 meters. Of course, both of them, they are going 100 meters. So this is basically what we have here, right? 100 meters by 0.8 by 0.15. The thickness of the wall is also 150. Right? The wall is also 150. I think here describes it better. 150. So this is 0.07. This is whatever it is here minus 150. We get this. All right. By 2, right? Because we have two walls. Now remember that this wall is to carry a slab. It is to carry a slab, and this part of it has already been created to be able to carry the slab. So what it simply means is at this point there won't be any concrete, right? And also, if you look at these details here, this reinforcement was also made to allow for such. You can see. All right, so it's basically what we have here. That's why you see here I have to remove that little part. I have to remove that little part. This is 80. Okay, this is 100 by the length, the width. This is the thickness of the concrete. This is 0.08, not 0.8. all right, see here, cover position 150 minus 70 is this 0.07. all right, so that's what we have. By 2, it is 2 sides, of course. And now we'll talk about the reinforcements. Having this talk about the concrete, of course, we just saw we did concrete for the base and concrete for the wall. The same thing for whatever type of concrete, it is to base, then to the walls, whether trapezoidal, whether V-drain, it is put to both the base and the wall. All right, reinforcement, and this is the nature of the reinforcement. It is a U form. It's in U form, just like this, right? So firstly, we need to do reinforcement for the main bars and then the runners. Some people separate it, they do base and then they do wall, whichever way you want to go about it. You do it for the main bars and then the runners. Now the main bars is the U part of the, see I showed us before. This is the main bars. These are the main bars. See, the one that forms the U is the main bar, while the other one that runs through the length is called, they are called the distribution bars. They're also called runners, right? Okay, now let's come back here and see how. So this is the main bar. We have 800 plus 150. That's the depth. The width here is 1300. 1300. We have cover of 25 mm. Of course, if you want to see the concrete, you want to see the reinforcement, you have to remove cover. Now, what is going to be the length of the main bar? What will be the length of the main bar? This is 800 plus 150. This is the width. This is another 950. Now see what happened here. This is 950, right? Now this is another, this is 1300, then another 950. Now this is what we have here. This is the main bar. This is one. This is 950. This is another one, and this is another one. Can we say I have this? Now this is a thick line. Look, this is a thin line. This is a thick line. Look at this thick line that forms this U, right? That is what we are talking about. That is what we are talking about. From here to here is 950. Of course, this no longer includes the blinding. You see, it's 1 meter, it's 1000. It does not include the blinding anymore. We're talking about the drainage now itself. So this is 950. This is 1300. This is another 950. Right. So, and of course, I need to remove cover. I need to remove cover from here if I must see this reinforcement, cover from here if I must see this reinforcement, and if I must see the reinforcement here also, I must remove cover because they are all inside concrete. So this will not be, this will be 75 plus, let me make it no, let me write it 75 because I already put minus. Right, how is it 75? It is 25, cover here 25, cover here 25, and cover for the reinforcement in the concrete here 25. Cover and cover. Now if I say 25 here to see cover, remove cover here, remove cover. What about the cover here? Because I already took the full length, and the full length is the length of the wall. Cover and kabani. Alright, so this is the length of the main bar. This is the length of the main bar. Now the next thing will be how many numbers am I going to have inside 100 meters? How many numbers am I going to have inside 100 meters? What did the drawing say is the spacing? What is it? The drawing says the main bar, it is, if you can see here, there are 250 center to center. 250, see it here. T12, 250 center to center. T12, 250 center to center. Alright. So this is, we are done. Alright, this is what we are. Okay. Now okay. I missed it. This is here. Alright, so now this is one part of it. This is another part of the main bar. Now if you can see, this main bar, the one outside, is longer than the one inside. You can see it. It is longer than the one inside. So all this we need to take into consideration. You don't say you have done one, you multiply by 2. You are wrong. Either you are wrong, right? Okay, now so we've done for this one running outside. We want to do for the one running inside. Of course, you can see here this is 800. This depth into in is 800. All right, so that's what we have here. This is 800, right? Now this is 1000 and another 800. This is what we did here. 800. Neighbor, this is 0.8, right? So what I'm taking is just here, here, here. That is what forms this reinforcement here. 800, 1 meter, 800, right? And of course this is inside. See this itself, 1 meter from here to here. This is even extending small, extending small. I will account for it, otherwise I'll be short paying myself. All right, so this is what we have here. Okay, this is it. This is 800, 1 meter, 800. Now if you look from the drawing, I have to less cover this. I have to less cover to see the reinforcement. This have to be 3 cover, 25, 25, 25, which is 75. There's something I observe also. Now if you look at, let me zoom it very well so that you see it. Right, now this is 1 meter from here to here, but this thing extends small. You can see it. This is where 1 meter end, right? This is extend small here, small here, small here, small. If we don't account for it, we'll be shooting ourselves in the leg if this is a job. So you have to account for it. So let's say we have, it is 50, 50. Let's see if maybe it's more than 50. Let me measure it. Okay, this is 20. Okay, the cover is 25. So 50, 50, 50, 50. So we are going to add 50, 50 into 4 to get that little. Otherwise, we will not be totally correct. That is what measurement requires. You have to be detailed. Let me bring it here. Add extension, which is 50, 50 into 450 by 4, right? That gives me 200. Then I less cover. So this is what I have. This is what is going to be. All right, so it is now for me to put everything I've gotten into the dimension sheet. Now this is what I have here. How many numbers am I going to have? How many numbers of that U bar or main bar I am going to have? My total length is 100,000 mm, which is 100,000, which is 100 meters. Right? If I divide by the spacing of 250, that's what I have here. Drain length is 100,000. Is in millimeter. Now the number of main bars will be 100,000 divided by 250, which is the spacing, like we saw in the drawing. Of course, we add 1. That gives me 401. Right? So our calculation here, the outer one is 3.13. Is 3.13. 3.1 or 3.15. We just calculated it. Why this is 2.73. 2.73. Right. We have a total of 401. That's why you see 401 here. Right, that is the main bar. Now we want to discuss distribution bar. Distribution bar. The drawing says distribution bar is T10. This is actually this description. Let me correct it. This drawing says that it is 250. Let me zoom in. Right, T12. It is T12. If it is T12, This is supposed to be 0.888, not, I used T20 888, right, for me to convert to ton. 10 to 6 mm diameter. Okay, that's the description. So it is T12. Alright, so distribution bar, we are told it is T10. Actually, the distribution bar is the one that runs through the length of the 100 meters. Alright, it runs and then tied to the main bar, tied to the main bar, tied to the main bar. The water, yes, it tied to the main bars. These are the runners. These are the runners of the distribution bars. So this is what I have. So this is the main bar. The distribution bar, the length is 100 meters. The length of distribution bar is running 100 meters. So how many number of distribution bar are we going to have? Remember, distribution bar is running the length of the main bar, and we have from the drawing now, we have two main bars. We have one in the external, which is the longer one, and we have the one in the internal, which is the shorter one. Kobankabane to Hankane. Alright, now they cannot be the same thing. And of course, if you can see the number of main bars on this one, the number of distribution bar is less than the number of distribution bar on the external drain. You have to pay attention to these details when it comes to measurement. Alright, so this is what I have in the main bar: 800, 13, 800. Is it 800 on the main bar? Let's go back to the drawing. It's 800. It is on the outside. It is 800 plus 150. Right? I'm doing the reinforcement. I've already removed cover. So it is 800 plus 150, which is 950. Hang on, let's see. Alright, so the main bar is 800. It is 950. 950 minus 25, which is 925. This is 925. That's the length of the main bar. 925 measurement. 925. Right? So for me to know how many bars will be on this particular reinforcement, it will be 3150. 3150 at 200 spacing. So we have 16.5, which is 17. We have 17 numbers, right? That will be on the external reinforcement that will be running 100 meter length. The same thing goes for the other one. This is 800, of course, that's into in 800, and then the width is 1000. This is what I'm talking about here. This is 800 depth, 800 depth. This is 1 meter. And of course, remember we said this is extending beyond. Is extending beyond, and we said it is 50 50 50 50. So we have to account for it, because that is what will determine the number of runners on that particular bar. Let's put it here, plus 2. Let me not put it like that. Plus bracket open. Let me put it in bracket so that when you study, you will know. 4 times 50. So this 4 times 50 is the extension of that internal main bar. See it here. From here to here is the 1000, but see, there's a little extension here and here, here and here. 50 mm, 50 mm, 50 and 50. There's no 50 mm there. I was one that assumed it to be 50 mm. Alright, because I don't want to leave it out and say it is 1 meter when it is beyond 1 meter. So so you have to allow for it. Okay, so that's why I just put it here so that you see it. So I'll include this here now. Here, plus 50 times 4. That gives me this. So 2800 divided by 15. I'll have 15 numbers on it. I'll have 15 numbers on it. Yes, yes. So that is it. All right. So how many runners am I going to be? So this is what we have here now. So the distribution bars or the runners, that's T10 0 to 200 center to center. This total number here is 17 numbers. So this is 17 numbers, and total number here is 15 numbers. And no, this is 0.616 for 10 mm. 0.616. Another person says 617. Right? So this is what we are. Now see, I added laps. Now because you are taking this reinforcement 100 meter direct, it cannot just be like that. There's going to be a rod. Highest is 11.7. It is down up to 12 meters. So at every point you are going to lap. You are going to lap it, some 800, some 1 meter, some even 1.2. So here you see I'm using a lap of 1 meter. Right? So total length is 100. That's 100,000 mm. But now is in, if I say 100 is in meter, divided by 11,700, I'm going to be having 8.5, which is 9 numbers. That's why you're seeing 9 here. That's why you're seeing 9 here. Right? So that is the reinforcement. Oh, that's the reinforcement basically. Measurement is in work on its own there. Alright. Now the formwork. The formwork. Of course, you know we have formwork to the base, we have formwork to the walls. Formwork to bases and formwork to walls. Right. Now to the bases, you know the length of the base is 100, the length of the drain is 100 meters or 100,000 mm. Right? And we have the base to be 150. So we have formwork on one side and the other side, and it's a linear meter item. It is a linear meter. Right, so 100 by 2 for 2 sides. Then these are the end side, 1.3 by 2. Right, now the same thing also we'll do for the side. The side 1.3 high. Yeah, it's 100 by 1.3 by 2. Then 100 by 0.8 by 2. Right, then these are the end sides. These 1.3 by 0.95, remember, without the blinding now, by 2, and this other end 1.3, that's the internal side, 1.3 by 0.8 by 2. So this is the formwork for the drain. Right? Okay. The cover slab is the same thing. The concrete, the reinforcement, and the formwork. Alright, let me take a little time to explain the cover slab. Now let's come back to this drawing. This is a section of the cover slab. This is a slab, right? Now this concrete, right? Now of course some persons will also use factor, use 70 kg per cubic meter, use 80 kg per cubic meter. Please calculate it. If you have a detailed drawing, if you don't have a detailed drawing, it's a different ball game. But if you have a detailed drawing, please calculate it. Right, and free yourself from unnecessary guesses. Alright, so let's come over here. The same thing for this drainage. Now I've got this, the cover, they are also they are number items. Alright, they are number items. So just permit me, we'll just run through them right away. Concrete reinforcement formwork. This is the total length. right? This is the width. The width is 500. The total length is 1.16. Of course, the concrete to be 1.16 by 0.5 by the thickness of the concrete. What's the thickness of this slab? You see it here. Section CC. Section CC. Right? So the thickness is 150. So let's come over to our measurement sheet. So 1.16 by 500, thickness is 150. That's what we saw in the drawing. The concrete is grade 5. So 1.16 by 0.5 by 0.15. We'll have 201 numbers. That's what I just explained. Total number is 100 divided by 0.5 plus 1. Let me take this one to millimeters. 100,000. Your waste calculation should be in, it will be the same thing, should be in millimeters. So I have 201 numbers. So this is 1.16 by 0.5 by 0.1 by 201. Now you see here I deduct. Now most times it is not necessary, but for exam situation it is necessary. See this place, right? We are told that we're given here somewhere. We're given this particular details somewhere. Bam, see it here. It's 0.03. It is 30 mm. You can see it here. See it here. I hope you can see it. It is 30. So that is what I had to deduct it. Right, but by the time it becomes many, though it is small, become meaningful. Right? So that is why I had to. Okay. So this is what we have. 0.6 is by 0.3 by 0.15. That is the dimension. You can check it out in the drawing. Right, 0.66 by this by 150, which is the thickness. So I had to deduct it. Alright, I know somebody will point it out. Yeah, I did not deduct this one. You have to deduct it. Alright, reinforcement is the same thing. Just what we did there. It is, see this is the detail here. Let's study the details quickly so that we'll come back and close this out. This is the detail here. This is 7012 04 200. I've explained this before. Alright, and the other ones, we have the horizontal and the vertical. Which one is the vertical? Okay, the horizontal is from my position now. This is the horizontal and this is the vertical. 72. Why the vertical is this? Reinforcement. The horizontal is 4012, which is this. While the vertical is 7012. Now if you see this, see my reinforcement, see this arrow here, look at where it's stopping here. This is it, right? Why this one? See this arrow here, it's on this horizontal element. All right, so let's quickly go back to our measurement and sort that out. So this is what we have. We have 4012 04 150 top and bottom, right? It is 1.11. See it here, 1160. I remove cover, right? 25 on both sides, 25 that gives me 50. See it here, this is minus 25 minus 25, right? That gives me 1.11 as the length of that particular reinforcement. We have 4 number of feet. It is 4012 by 201, which is the total number of slab you are going to be having on that 100,000 millimeter drain or 100 meter drain. All right, the same thing goes for the vertical bars. It is 7012. Excuse me, it is 500. All right, it's running through 500. If I remove cover, it remains 450. 0.45. We have 7 number multiplied by 7 multiplied by 201. Now remember, this is Excel, right? Okay, let me see if it will work. Let me try something. Let's see if I put it here, if it will stay. Yeah, it stayed though. Okay, let me remove this. Let me remove this one. All right, it will. Okay, let me put. Okay, still there. All right, now this is exactly how your takeoff sheet is. All right, so multiply by 7, multiply by 7, multiply by 201. Let me put it here also. Let me first of all remove this guy. Let me bring this one here. All right, so multiply by 4, multiply by 201. All right, so that is it. So the formwork is also the same thing. All right, you have formwork to the side, you have formwork to the base, right? Because you have to cast it. You can't just cast it on the ground. So now you cast it on the formwork or you cast it on a concrete surface, right? But in this case, we cannot say there's a concrete surface. We have to cast it on a formwork at the base, some formwork to surface of drain cover or base. All right, so this is 1.16 by 0.5, which is that. All right, and also to the side also, which is 1.22, which is this here, by of course by 201. Why this 0.5 part by 201 number? And I'm going to say, but would it not deduct that side we deduct in the concrete? Well, we can also deduct it if we want, but I say to be very minimal. But for exam purpose, let me carry everything from here and bring it here so that I can do that deduction. Am I right? So that we'll do the deduction so that you see. All right, so I can remove this now. I just moved that one up there so I can have space here. All right, so this goes. Not because I've already moved it up here. I just want to. What line is this? I just want to show this deduction here. Okay. So if I deduct, this would be 0.66 by 0.03. By 2. Okay, let me remove this first. I'll stay here. By 2 by 201. Right? Let me put it in red so that you know that I'm deducting. That's what we just deducted. I'm right? 0.66 by 0.03, which is 30 mm. All right. This is yes, this is okay. This is okay. All right. So that is basically what we have. All right, so this one is to the side. Now of course to the side, you see we have to take it together with the shape. All right, so that is basically what you see, plus 30 here, took it together with the shape. So this is basically how you measure drainage including the cover. Right, as you can see it took time, so because it requires even the smallest level of detail, you have to pay attention to it, especially even if you're not writing for exam. Once you are preparing a work for somebody or you're doing a particular job, you have to pay good attention to detail. All right, I hope this helps you academically. I hope it adds up to your knowledge, or it reminds you of something, helps you in your professional career, or you still in school, helps you in your academics. All right, so this is basically how you measure drainage, whether it's a U drain, whether it's a V drain or a trapezoidal drain. It has base, it has walls, and of course maybe some minor excavation and cutaway. All right, thank you very much. Please watch, learn, like, comment, subscribe on our channel. All right, when you comment, when you like, it helps YouTube to share the video to a wider audience, so that others in the profession can also see the video and learn from it. All right, this is Chaka Quantics. I'll see you in the next video. Thank you.